Hello everyone! Today we're gonna talk about shearing stress. This is a type of stress that is totally different to the normal stress on members. Shearing stress is created by transverse forces applied to a member, as shown in the figure. So here we have our member and we have force P on top and force P at the bottom. Those are the transverse forces, which are external forces applied to the member. In this case, it is important to notice that those forces are not applied along the axis of the member. To better understand the concept of shearing stress, it is necessary to analyze the internal forces of the member. This can be done by making a cut at a point of interest. In this case, I will make a cut at point B. Now, let's just take section BB and analyze the internal loading. Once we have drawn section BB, we can see that the internal loadings that a member might have will be the normal force, which is the force perpendicular to our cross-section area, the shearing force, which is the tangential force that acts on the surface, and the bending moment. Based on the free body diagram and the equilibrium equations, we can use the sum of all the forces along the x direction equal to 0 so we can obtain the value of the shearing force. Once we sum all the forces acting in the x direction and made them equal to 0, we can see that in this case, our shear force is equal to the external applied force. In this case, V is equal to P. In other words, the magnitude of P and the shearing force will be the same. Once we have explained the importance of analyzing the internal loads in a member, we can go ahead and introduce the definition of shearing stress. Average shearing stress is defined to be the force per unit area that is created when a tangential force acts on a surface. Furthermore, the shearing stress can be obtained by dividing the internal shearing force by the cross-sectional area. Here we have the equation that we need to use when we want to find the average shearing stress. Tau is equal to V, which is the shearing force, divided by the cross-sectional area of the member. It is important to notice that the cross-sectional area and the shearing force, in the case of shearing stress, must be always parallel. And just to mention the applications of this concept, shearing stress is typically found in bolts, pins, and rivets, which are used to connect several types of structural members. In the next video, I will be talking about two different types of average shearing stress, which are the single shearing stress and the double shearing stress. Thank you for watching the video. See you next time.